Hello, today we're going to learn how to find the distance between 2 points on a coordinate plane. So we're having a Valentine's competition, so excuse the ridiculous amount of pink today. Let's choose the points for -3 and 2, 4. So sometimes you will just be given 2 points. And from those 2 points, they ask you what's the distance between those 2 points. There's a couple different ways you could do this. One suggestion is to take a coordinate plane and you go ahead and you graph those 2 points. So I go 4, -3, and then 2, 4. And what you're trying to find is the distance, a straight line. To do this on a coordinate plane, you would just make a right triangle and then use the Pythagorean theorem. So here we have 2 as a side, and here we have 1, 2, 3, 4, 5, 6, 7. And you would use a squared plus b squared equals c squared. However, if you don't have a coordinate plane handy, that's okay. You can still sketch it out here, or you could figure out what the legs are simply by using the points here. So if you sketched it out on a coordinate plane, and these would just be approximate, right? You just go over 1, 2, 3, 4, 1, 2, 3, and then 2, and 1, 2, 3, 4. This would just be a little sketch, and it's not going to be drawn to scale. But you know the difference in the height is going to be the difference in the y values from here to here. So let's take a look at our y values. So from -3 up to 4, well, that's 3 here and 4 there, so that's going to be a difference of 7. So our change in y is 7, and our change in x, right, from 2 to 4, the change in x is going to be 2. Now, some of you might be saying, oh, wait, but when we did change in y, remember you have to subtract the same way. Yes, if we were looking for slope, you would definitely make sure that, right, this was -7, okay, because the height is dropping. However, we're dealing with distance. We're just looking for the absolute value change in y and the absolute value of change in x. Either way, these become our legs. And if you want to label them 7 and 2, that would work, but you're still going to use a squared plus b squared equals c squared. Now a squared, let's make that 2 squared plus b squared, 7 squared equals c squared. So 4 plus 49 equals c squared. So 53 equals c squared, but I need to find c. So the opposite of squaring a number is square rooting. So we'll square root both sides of the equation. C over here, and the square root of 53. Now you have to look at the directions. Do they want you to reduce this, put it in simplest radical form, or do they want you to approximate? Either way, I would use a calculator. And on our school's calculators, you would just type in the square root of 53 and hit the enter button. And here it says it cannot be reduced any more. Or you hit this change button and it will approximate. Now typically if they're having you approximate a square root, they will ask you to round to the nearest tenth. So in this case we're going to do 7.3. So C is approximately 7.3. And we don't know the units because they didn't tell us. Okay, so let's go ahead and look at another problem. Let's have at least 2 examples. Let's look at a problem with 2 points of -7, -1, and 1, -8. You could sketch it out, and -7, -1, and 1, -8 will be something like this. But we're interested in the right angle that's formed between these 2 points. Now, to get the height of our triangle here, we're going to look at our y values. And the y value at this one is -1, and it drops down to, so that's a difference of 7. And our change in x here, we went from a -7 all the way up to a 1. So that's a change of 8. So I'm going to go ahead and label. Oftentimes with triangles, just doing a quick sketch will help you process the problem a little bit better. We're still going to use the Pythagorean theorem, so a squared plus b squared equals c squared. A squared is going to be 7. I typically always choose the smaller of the legs to be a. So 49 plus 64 equals c squared. So we have 113 equals c squared. Once again, we'll take the square root of both sides, and let me rewrite it as 113. Square root of 113 equals c, and c is approximately 10.6. Now, some of you may have learned the distance formula, and the distance formula is great. If you like formulas, you like to plug into formulas, and you want to use it, then absolutely use the distance formula. However, that's going to be something that you put over here on the left side. It basically goes through how to use just the points and find the change in y and change in x, and just put it into this form without kind of working it through. It's kind of a plug and go system. And there's nothing wrong with a plug and go system. However, I find that when students are too reliant on formulas in a plug and go system, they don't understand why they work. I much rather a student understand how to set up the problem and make it work. That way, it doesn't matter if you were told a point and one of the leg sizes, right? Or a point in both leg sizes and they're asking for the other point. Or they're not even giving you a coordinate plane at all or points, and they're just giving you a hypotenuse or the legs, and you're trying to find the missing one. If you understand the Pythagorean theorem, both on a coordinate plane and just in a diagram, then you're going to understand how to do a lot more problems than if you just know the distance formula. However, I am going to put the distance formula up here, and if you want to figure out how it works and why it works, then absolutely, it's real long, go ahead and put this in there, okay? So you're going to take x2 minus x1, you're going to square that, and you're going to add it to y2 minus y1, and you're going to square that one. It means it's the same thing and you get the same answer, but even a lot of students this way, it's a little bit faster. But try it out, see if you can get it to work. Maybe try out these two problems, then maybe try out your own. Okay? Thank you.